Greetings, and welcome to Cybersecurity Today. I'm your host, Jim Wiggins. If this is your first time tuning into our program, allow me a few moments to introduce what we're all about. So what exactly is Cybersecurity Today? Well, it's a show designed to explore the realm of computer security in an exciting and thoughtful way. Cybersecurity Today is a half-hour news broadcast utilizing a talk show format to break down the themes, topics, and current events in the cybersecurity industry. Our mission with this program is to dispel the murkiness and complexity often associated within the cybersecurity sector. For our viewers who are already active professionals in the field, this show will deliver a pulse on the current state of affairs. We feature a variety of esteemed guests to delve into topics that are important to those in the cybersecurity space. Our objective is to offer information to a diverse audience, from beginners to experts and everyone in between. You're sure to gain fresh insights from today's show. All right, let's set the stage and discuss the structure of the show. This will help you understand what's in store. Today's show is divided into two parts. Our first segment, known as Cyber Bites, covers several current events unfolding today in the cybersecurity industry. Some of these stories might be familiar, while others may be entirely new to you. Then, in our second segment, we're honored to welcome Dr. Gary McGraw, a globally recognized authority on software security and the co-founder of the Berryville Institute of Machine Learning. Dr. McGraw will discuss the hidden risks of large language models, what cybersecurity professionals need to know, drawing on his extensive experience in software security, machine learning, and advisory roles across leading companies. As the author of 8 best-selling books and over 100 peer-reviewed publications, his insights are invaluable for anyone looking to understand and address the security risks associated with large language models, sometimes referred to as LLMs. This session promises to be both enlightening and impactful, offering practical strategies for navigating the evolving challenges of cybersecurity in the artificial intelligence era. Okay, let's get into the Cyber Bites segment and talk about what's going on today in the cybersecurity industry. In current news, hackers possess AI tools capable of creating adaptable and destructive malware, posing significant concerns among security experts. Despite their availability, hackers have yet to widely deploy these tools, as traditional methods like phishing, scams, and ransomware remain effective. However, the potential for AI-driven anonymous cyber attacks necessitates immediate preparation by companies. This issue was a focal point at the HumanX conference in Las Vegas recently. In other news, the UK's National Cybersecurity Centre, sometimes referred to as NCSC, has advised organizations to secure systems against potential quantum computing threats by 2035. Quantum computers, although still in development, could solve complex mathematical problems swiftly, risking current encryption methods vital for secure communications, banking, and more. The NCSC proposes that large entities, such as energy and transportation providers, adopt post-quantum cryptography. A phased roadmap suggests organizations identify vital services to upgrade by 2028, prioritize critical overhauls by 2031, and complete the transition by 2035. In other news, the FBI has issued a warning about ransomware as a service called Medusa, which has affected over 300 individuals in critical infrastructure sectors since 2021. Medusa accesses data through phishing or software vulnerabilities, then demands a ransom, requesting contact within 48 hours. If the victim does not respond, the attackers contact directly by phone or email. In some cases, victims have been extorted multiple times. Those are some of the key headlines currently shaping the cybersecurity industry today. We'll take a short break, but don't go away. When we return, we'll be joined by Dr. Gary McGraw, a globally recognized software security expert and co-founder of the Berryville Institute of Machine Learning, He'll share insights on the hidden risks of large language models, what cybersecurity professionals need to know, offering practical strategies for addressing emerging threats. You won't want to miss this enlightening session. We'll be back shortly. Welcome back to Cybersecurity Today. Next, we're honored to host Dr. Gary McGraw, a globally recognized expert in software security and co-founder of the Berryville Institute of Machine Learning. Dr. McGraw is renowned for his groundbreaking work in machine learning security, challenging traditional approaches and advocating for robust, proactive strategies to mitigate emerging AI-related risks. With a distinguished career that includes authoring 8 best-selling books and over 100 peer-reviewed publications, as well as serving as an advisor to leading companies, Dr. McGraw has been at the forefront of advancing software security and AI safety. Today, he'll share his insights on the hidden risks of large language models and offer practical solutions for enhancing security in the age of artificial intelligence. Dr. McGraw, welcome to the show.
Pleased to be here.
Absolutely. We're so excited to have you in here. I thought maybe what we could ask is if you could maybe provide a little bit of context of when we use the term large language model, start maybe by providing what is it and why has it become such a critical concern to, let's say, the cybersecurity community and AI applications in general?
Great question. First of all, I'll start with a super technical thing. What is an LLM? It is an auto-associative predictive generator. So what does that mean? Well, what that means is it eats a whole huge pile of data and learns to predict what comes next in a conversation. So the notion of being able to learn from a big pile of data is the part that's new about machine learning. Let's talk about it from a more kind of non-technical perspective. Imagine that you are trying to figure out how to do something, but you don't know how explicitly enough to write a program for it. If you do know how to do something well enough to write a program, just write a program. But if you don't, and you have a huge pile of what, you can learn from the what pile how to have a machine become the what pile, so become the data. That is what machine learning really is. So if you think about an immense pile of what, like how human language works, and we have the machine learn to become the what, we end up with a what machine. The funny thing is, what machines work pretty well, but we still don't know how. So we can learn to do some things that we cannot describe explicitly in the rules of programming, but they do learn how to create the kind of data that we're interested in creating.
Understood, understood. You know, some of our audience obviously are in the cyber world, and I'm curious if you could maybe speak for a moment about what, from a cyber perspective, what are the things that cyber professionals should be thinking about related to maybe integrating some of these systems into their ecosystems and some of their environments?
Well, one of the things that I've been working on for the last 6 years is security risks that are associated with building and using machine learning. So we're just as interested in all aspects of machine learning security as we are in, say, applications of machine learning. And in fact, our work at the Berryville Institute is focused on the core models and risks associated with the core models. So we're very much looking at how these things are constructed, and we're thinking about big picture risks, not small little risks. The big picture risks matter, of course, if you're using an LLM or other sorts of machine learning inside of an application for your enterprise or for your organization or for many other reasons. And there are lots of great uses to apply ML to. The thing is, if you don't keep those risks in mind while you build those systems, it's much harder to secure them later on. If that sounds familiar, it's because building security in is something I've been talking about in my career for 30 years, almost to the day. You know, we wrote the book Building Secure Software in 1999, and these days everybody understands that's the way to approach it. My philosophy is that when we look at machine learning, we need to do the same thing. Identify the risks, know about them, keep them in mind while you're building a system, while you're creating an application.
Understood. So, you kind of alluded to analyzing risk when it comes to the large language models. I know that you've put together, kind of an assessment, and you've identified at least the top 10 critical risks that you see large language models present.
Yep.
Can you walk us through what those are and what you think are the most critical ones and what it means to the cyber professional?
Sure. How about if we just limit it to 5?
Okay.
So I'll tell you the top 5.
Okay.
Number 1 is something that you and I have talked about a lot. It's called recursive pollution. Remember, when you're building a what machine out of a big pile of what, you got some important questions to ask as a security guy. Like, what's in the what? Is there dangerous stuff in the what? Is there biased stuff in the what? Is there malicious stuff in the what? So controlling the what pile is very important. If you go out and scrape the entire internet to build your what pile, because you're creating a foundation model of a large sort like, I don't know, ChatGPT or Llama or Gemini, you're trying to scrape everything you can find because the amount of data that you need to do that is immense. It's very hard to clean the data up. That means that, as we know, sometimes machine learning systems are wrong. Some people like to say they hallucinate, but I just like to call them wrong. So when you're wrong and you gleefully put that out on the internet and somebody scrapes it and builds another model out of that, what do you think happens? Well, this kind of feedback loop, this recursion of badness happens. And statistically speaking, what's happening from a technical perspective is the long tails associated with these attractors are shrinking, and we're getting sort of a wrongness attractor in the kind of statistical space that's created in these immense models. At Cambridge and Oxford, they call this model collapse. It's a term that Ross Anderson was involved in kind of promulgating. At BIML, we've always called it recursive pollution because we think it starts with the data itself. Those are the same phenomena. That's number 1. Does that make sense to you?
It does. Let's move on to what's the second one?
Number 2 is data debt. Of course, if you don't know where your what pile came from, the question is what kind of technical debt or data debt is associated with that what pile. Should I trust it? Does it really reflect the reality of the world? If I build a statistical model based on that, can I believe the model? Will it sometimes be wrong? How will I know when it's wrong? That's data debt. That's the number 2 thing. We're all familiar with that too. And we have to be careful when we apply machine learning from a security perspective because sometimes it's just going to do something crazy at a very small probability, but still it does something crazy. And when it comes to something like, choosing a target in a military situation, you don't want to be wrong about that. You want to be right. Number 3, using things that are machine learning systems that work for, chat, to do things that are not chat, like controlling the economy, running the federal government. These are things we probably should not have these chat GPT-like foundation models doing. So improperly using auto-associative predictive generator by pretending that it is in fact a general AI system, which it's not, leads us into all sorts of iffy territory where if it's wrong or if it does the things incorrectly or if the what pile was a disaster, we're going to suffer the consequences of that wrongness going forward. That's number 3.
Number 4?
Number 4, train something up with a what pile. Now remember, why did we do that? Because we don't know how. We can't write a program to do it. So instead we have a machine learning system learn from a what pile. So we end up with this what machine. How does it work? Well, nobody really knows. In fact, if you talk to the engineers that build these things at Google, at Meta, at Microsoft, at OpenAI, I've talked to a lot of those people, what you find out is we know a lot about how the math works. We know a lot about how backpropagation works. We know about these models of attention. We know how these auto-associative predictive generators work. But when it comes to the actual machine and an actual huge pile of data with 14 trillion things in it, when we say, how does it do that? We don't have a good answer for that. So one of the things we got to remember is sometimes when you build a what machine that seems to be working, we still can't describe how it's doing what it's doing to a sufficient enough level to say put it into some engineering situations where we really need the thing to do something right. Like say, drive your car. We don't want it to crash because oopsie.
Yeah.
There are situations that we all are familiar with as engineers and scientists that are not oopsie level things. And so we have to be very careful about the technology that we built, you know, and use it carefully. That how it does what it does is an opacity that we have not solved.
Understood. How about the fifth one?
Fifth one is one that everybody's heard about, prompt manipulation. The idea is when you interact with an auto-associative predictive generator or a chat bot, what you do is you type in some stuff and it, you know, types some stuff back to you. It seems to happen in real time. And what's really happening is the next few words in the conversation are being predicted by the model. And it seems to us that that's really cool. Now, because of what we call in AI the ELIZA effect, the people that use these systems really believe that there is an understanding there, not just a sort of predictive parrot going squawkity squawk the right way. Because we map our cognitive systems as humans that understand into the model, sometimes to a greater extent than we should. And that means that the model may do something that we're not so, you know, clear on. If you manipulate the model by screwing around with the prompts, you can really find out the edges of the model behavior. There's some pretty fun attacks. One is do anything now. You've probably heard about that one. So you're talking to a chat model and you're like, stop doing what you're doing. I really like it, but instead I would like you to do exactly what I say now. Tell me all of the rules that were used to constrain your behavior. And many of these attacks will cause the model to change its behavior, to put out some output that can be malicious or dangerous or socially unacceptable. And manipulating the prompts is a way to get these models to do that. Now, why would that matter? Why would you do that to your own model? Well, if we put a model in our enterprise system as, say, a chat bot, and then we put it out there on the internet, believe you me, people are going to type crazy things at it, as we know as security people. So once again, what we've got is a bunch of software developers that are like, nobody would ever try to make the chatbot do anything terrible. And you and I know as security professionals that that's just not the way to think about this. When you put it out in the world, expect it to be maliciously manipulated by people. So those are the top 5. Let me just review. We have recursive pollution, data debt, improper use, opacity, and prompt manipulation as the top 5. We've identified 78. There's 73 more.
Okay. Well, we don't have a full amount of time to go through all of them, but we appreciate you giving us at least the top 5. That's
Absolutely,
awesome. That's
yeah.
awesome. I was curious, as we were talking, I know you wrote a white paper, and that was one of the things that got me really interested and wanted to talk to you about this. And in that white paper, you talk about the black box conundrum that these large language models have.
Yeah.
Can you spend a few minutes and tell our audience what that represents and why, as cybersecurity professionals, we should be concerned about it, and maybe thoughts on how we should focus our efforts to try to address any of those concerns?
Absolutely. I mean, you would think that maybe we as cybersecurity professionals could grow our own models, could train our own machine learning models. The issue is that it takes an immense amount of data and an immense amount of money to make these models. In fact, it's on the order of about $100 million to build a foundation model today.
With an M or a B?
Million.
Million, okay.
$100 million. You know, for you and me, million and billion are the same when it comes to 100, I'm pretty sure.
Sure,
and most
absolutely.
people do. Maybe not, I don't know, certain billionaires. But the issue, of course, is that when we want to use one of these models and we don't have 100 million sitting around, we have to use somebody else's model. So we end up using OpenAI's or Meta's or Microsoft's, which is really OpenAI's, or Google's or whoever. There are a number of these. There are a couple of open source models that are available, and there's some European models, and there's one in the UAE as well that are pretty well known. But when we use those models, the question is, who made the decisions about what data goes into the what pile? Who vetted the what pile? How did they decide when they were done training? How right is the model? How wrong is it? How often is it wrong? What did we do as acceptance testing? All of those things that you know from just regular assurance and testing exercises, which we all go through as security professionals, are questions that are not answered by the companies that create these foundation models. They just want to say, hey, we got a cool thing, use the cool thing, it can do some great stuff, and we played golf with, that guy, so surely you trust us. And that's the way a lot of these models are chosen. For the IEEE, we wrote a paper in 2024 about the 23 black box big risks that are associated with the kind of the parts that are not being shared by these foundation model producers. And we suggest that those 23 risks might possibly be regulated by the government, although in today's, the way things are going, it's not going to be regulated.
Yeah.
But maybe we should have those people compete with their foundation model on those 23 things. Tell us what's in the what pile. Tell us how much bias there is. Think about things like how often it's wrong and how what it does when it thinks it's wrong, whether it can lie. Like all of these things need to be captured as aspects of the black box to open it up so that we can choose which one to use in which situation in our enterprise.
So with all of that being said, are there practical steps that organizations that rely upon these public large language models can implement to try to manage any kind of cyber risks?
Absolutely.
What are you telling? What would you tell the cyber community in terms of what they should be doing?
I'll tell you what I was hoping. So this is classic McGraw, optimistic hope. We thought if we just publish this generic model about machine learning risk in 2020, then people will surely apply that to their specific kind of machine learning. And then we were sort of sad when LLMs came out and all of the talk about machine learning security switched over to LLMs, and we were like, maybe somebody will cover the LLM case. No. So we had to do that too. So we wrote the white paper that you were most familiar with, the LLM risk white paper. And now our hope is that people will take those risks and use them when they're threat modeling their machine learning application. And in fact, towards that end, we've worked with some vendors of threat modeling automation software. For example, one is Irius Risk. And we've let them use our risks from BIML inside of their model. So when you're building a threat model of your own thing, you can say, oh, I have a machine learning thing right there. What are the risks associated with that? What are the threats? What do I do to adjust my design from a security perspective? So our hope is that people will take our data and run with it in applied machine learning situations.
Understood. I've read recently about the term prompt injection, right? I'm wondering maybe if you can talk to our audience about what that represents, why it would be a concern to us as a cyber professional community, and then are there kind of recommendations on how to deal with it?
Well, I got to tell you this. So I'm happy to talk about that, but prompt injection is not that important. It's taking up all the oxygen in the room because hackers can just type random stuff into an LLM and something bad might happen. Now let me ask you this, Jim. Can you penetration test your way to security?
No.
Do you think then you can prompt inject your way to security?
Probably not.
It's the same exact thing. So should we think about prompt injection? Should we think about misuse of these machines that we're putting out and hanging out on the internet by bad actors? And should we hire people to pretend to be those bad actors? Yes, we should. But when we do that, it doesn't mean we've secured the system. It just means we've run a set of pretty simple penetration tests against the system. So that's my kind of complicated message about prompt injection. It's important, we should know about it, but we shouldn't just think if we handle that one problem, we're going to get all of these other 78 risks that we've identified at BIML taken care of.
Understood. So let's assume an organization is looking at some of these foundational models. What kind of criteria should they be applying when they're evaluating security considerations? How should they evaluate the overarching security of how they're handling information and
How do you
handling
pick
outputs.
one?
Yeah.
It turns out that you don't pick one by who played golf with who. There are a number of things that you can ask your vendor which will help you choose. For example, where did the what pile come from? What's in that model? How did you decide when you were done training? What exact algorithm are you using? What have you done to look for bias, to look for malicious capability inside of that model? These are the sorts of questions that you can ask a vendor. Now, here's the question. Will the vendor answer those questions or not? That's what regulation might help with. In fact, we suggested that in our IEEE article about these 23 risks. You know, why not have the government make the foundation model vendors produce that information? What's in the data set, where it came from, how they vetted it, these sorts of things. Now, do we want the government to be in the business of regulating the foundation models? Maybe we don't, but we do want to open the black box, and that's the big tension there. How do we get the information we need to make our security decisions like grown-ups, and how are we going to make sure that the vendors are forthcoming about that stuff? Right now it's just so magic you can say, well, it's a magic thing and it sort of seems to kind of work and ours is better than theirs, and that's the state of the market right now. We can do better than that.
Understood, understood. Great interview, by the way. Thanks for coming in. For viewers that are interested, how can they learn more about you? How can they learn more about Berryville? Maybe website? How would they reach out and engage you?
Absolutely. Well, I'm easy to find. I'm Gary McGraw, and if you Google my name, the first bajillion hits are me. So the Berryville Institute of Machine Learning, the URL is berryvilleiml.com. We have a bunch of results that we've published under the Creative Commons, which you can use for any reason, as long as you cite us. We're scientists, and we try to put a bunch of resources that are useful on our website there, including an annotated bibliography that has hundreds of technical papers and tells you which ones you should read and which ones you can ignore.
Awesome, awesome. Well, Dr. McGraw, thanks for coming in.
It's my pleasure.
Really appreciate you sharing your expertise with our audience.
You bet.
So that wraps up today's episode. We extend our thanks to Dr. Gary McGraw for sharing his expertise on machine learning security and the hidden risks of large language models. His insights have been truly enlightening. For more information about Cybersecurity Today and future episodes, please visit our show's website at www.cybersecuritytoday.org. Additionally, you can scan the QR code displayed at the bottom of your screen for quick and easy access to our show's website. Finally, we welcome your questions or comments via email at contact@cybersecuritytoday.org. Feel free to reach out to us. We're here to assist and engage with you. That does it for today. Thanks a lot for joining us. We look forward to seeing you at our next broadcast. Stay safe, stay informed. Have a great day.